find a basis and state the dimension of the subspace H. So we got a subspace. We need to find dimension of this subspace. Okay, and we can find a basis and the number of vectors. The number of vectors in a basis is dimension. Okay, so this H, this subspace, is a collection of all vectors in this form, and we can write this vector as s and t. So there are two variables, so s times something plus t times something, because we got two variables. S and t are any real number. Okay, 1s 1t, so 1 1, 2s 2, there is no t, 0, 3s there is a 3, minus t is negative 1, and there is no s, 0, minus t means negative 1. Okay, so this one is the whole. Then we can write H is just generated by these two vectors. Okay, 1 2 3 0, 1 0, negative 1, negative 1. I meant this H is span of these two. Okay, so we can write H as span of these two vectors. I mean, you don't need to write this. If they are linearly independent, then they form a basis. Since we got only two vectors here, so we don't even need to write these two things. Okay, we got two vectors, and these two vectors are not multiples of each other. That means these two vectors are linearly independent. Okay, because when we have only two vectors, it's easy to see if they are linearly independent or not. Okay, so we got two. So note that the vectors are linearly independent because one is not a multiple of another. Okay, since one vector is not multiple of another, you cannot produce this by multiplying by any number. That means these two form a basis for this H. So a basis, by the way, is just, I want to call this B1 and I want to call this B2. So I can just write here basis is just B1 and B2, where B1 and B2 are given here. Okay, that's a basis. And what is the dimension of this subspace? Because we got two basis elements, just two. Okay, so here I was naming this is V1, V2, and or you could list those two vectors here.